Alright, so 21. 21 is just true or false questions. Letter T for true and letter F for false. Okay, let's take on these questions one by one. Let's read the first one. An object can have constant speed when its velocity is changing. Yes, let me explain to you why. Velocity, right, is actually, we call it a vector quantity because it's something that can be changed either by its magnitude changing or its direction changing. What do I mean by magnitude? I mean velocity is basically speed and direction. If either speed or direction changes, right, then the velocity changes now. So in this case, right, yes, the what happens if an object has constant speed but its direction got changed? Then yes, the velocity will change, but its speed will still stay constant, therefore it is possible and therefore this is true. Next one. An object can have constant velocity when its speed is changing. No, when the speed is changing, the velocity is instantly changing. This is false. And now the last one is something that needs a little bit more understanding, but it's still pretty straightforward. I think it's okay. Let's go. An object can still be accelerating if its velocity is 0. I just want you to think about this. Let's say you are holding a ball in your hand. I can't draw hands very well. I'm just going to draw a cartoon one. And right, you already released this ball, but it is exactly at the moment you release this ball, there's only one force on the ball and it is your weight. Therefore, if there's a force on the ball that is already accelerating, however, you just released it, so does it have a speed yet? No, but it's already accelerating the moment you released it. Therefore, an object can be accelerating even if its velocity is 0, as we can see from this demonstration of dropping a ball from a hand. Therefore, it is true that an object can be accelerating if its velocity is 0. Last one is just graph drawing and we are done. Okay, let's sketch the velocity time graphs for the following. A free falling object. Okay, let's tackle it. Free falling object should be super simple. We know that it is accelerating, and we also know that it's a constant acceleration. How I like to teach is actually, we can actually start plotting the acceleration first. So the moment we see the word acceleration, we can just plot from here to here. We know that the speed is going to go up. Then after that, it's just how we get from plot to plot. So for constant, the gradient has to be the same, and if it has to be the same, then it's just simply a straight line from plot to plot, like this. Yes. Alright, let's go for part B. Similarly, we just draw a VT graph again. Then now we need to understand what is happening. An object is falling, so therefore there is acceleration already. But is it experiencing air resistance? Yes, it is. Therefore, this acceleration is not uniform and is in fact decreasing as air resistance increases. Therefore, it's decreasing acceleration. Let's do our plotting first. We plot like this because we know it's accelerating. However, because it is decreasing, the gradient has to decrease as time passes. It's basically saying that acceleration is still positive but is lowering in magnitude. Therefore, we need to draw it like this. Let me explain why. It's because when we take the gradient at the earlier parts, you see, like let's say here, it's like fairly steep, and then when we take it at the start, it is very steep, and when we take it at the end, it is not very steep. Therefore, we know that the gradient is decreasing, and therefore it is a decreasing acceleration, which fits the context of the question. And for our final one, before you can rest, let's draw one more VT graph. Okay, let's read this. A ball being dropped from a height and rebounding when hitting the ground. Okay, a ball is being dropped from a height, so we know it's a constant acceleration, like part A. Okay, so let's just copy part A's graph first. Okay, like that. Simple. but then it rebounds when hitting the ground, and when it rebounds, you realize that let me draw a ball here right here. When it hits the floor, it's basically slow, then suddenly you speed up. But then when it hits here, does it just go back slow, then it speeds up towards space? No, it doesn't. It actually rebounds back with the same speed it had coming towards it. So what we do is we literally have to take this line and we mirror it in the negative direction, if you get what I mean. So in this case, because there's a direction change, we need to draw our axis like this. We literally take this line like this. I'm just gonna copy this line, in fact. Then we paste and we put it around here. So what it's doing is literally mirroring the earlier line and just in the opposite direction. Then we just take the top of this line and join it to the bottom of this line, and we are done. One thing I would like to actually stress is that this green area should be smaller than this pink area. Why I say that is because the green area is the height that it actually bounces back up, while the pink area is the height that the ball is dropped from. And using our knowledge of other physics principles, like the principle of conservation of energy, we know that when we bounce a ball from a height, the rebound height cannot be higher. If it's a perfect theoretical world, then the rebound height can only be the same as the height that it was dropped, assuming no other energy source or force was given to this ball during its journey. Anyways, that is the end for our introduction to kinematics. I know the questions weren't that easy that you would expect from an introduction, but they are made such that you can really finish this worksheet or video with a very strong base in kinematics lah, so you can tackle almost any exam question. Okay, anyways, that's all. If you have any issues, just email the account, or you can text me, or any ways of communication you have with me, just go right ahead. Okay, anyways, that is all.